So, why do we use binary? Well, if we look at pretty much most electronic items that have a CPU, so by a CPU we mean a central processing unit, which some people refer to as the brain of the device. It's the thing that kind of makes the decisions and processes data. Here is an Apple motherboard from the iPhone 11 Pro, and we can see in red here the CPU is highlighted, okay, with the red border. Now, if we could see inside that CPU, if we use maybe an electron microscope to see very tiny things that are in it, we would see the CPU is made up of what we call transistors, okay, or you might know them as switches. And these transistors or switches can be in either of two states. They can either be on or they can be off. They can't be anything in between. Think of it like a light switch. A light switch can only be on or off. Okay, and all of these transistors in the CPU that make the decisions for the program we run can only be in a on or off position depending on the data that they're processing. So this is kind of why we use binary. Okay, so to put it in some context, as humans, we use what we call a base 10 number system, okay, or sometimes called denary. Now, as we do this, we use columns. So we've got a column for units here, column for tens, column for hundreds, column for thousands, and you'll notice each time we go up a column, it increases by a factor of 10. So if we wanted the number 724, we'd have 7 hundreds, 2 tens, 4 units. Okay, and in these columns we can use any number from 0 to 9. I couldn't, however, put, for example, a number like 19 in there. I'd have to go to another column to get a 10,000. Okay, so we can only use the numbers 0 to 9 in our number system. People think we have this number system because we have 10 fingers. That's why they think it came about. However, as we've just seen, computers are different, and they use the system that we've mentioned called binary. Okay, we also call this base 2. And the reason we use binary is, as I said, the switches on a CPU can only be in an on or off position, only two things. And in binary, this is represented by two numbers, a 0 for off and a 1 for on. Okay, so the transistors, remember, can only be off or on. So we represent that in binary as a 0 or a 1. Okay, now when we're expressing a binary number, we can use, much like we did with denary numbers, we can use columns. Okay, so we start over here and we put a 1. Okay, then we double it for the next column, 2, double it, 4, double it, 8, double it, 16, double it, 32, double it, 64, double it, 128. We could go further, but I'm just going to use 8 bits here, each one of these columns being what we call a bit. And when we're dealing with binary numbers, the thing we put inside the column to indicate if we've got that number or not, we can only use a 0 or a 1. Okay, now remember in base 10 we can use any number from 0 to 9. We can't do that in binary, we can only use 0 and 1. Okay, so this is how it works. Let's say, for example, we're looking to convert the denary number 45 into binary. So I'm going to start over here at 128. And I'm going to think to myself, right, how many 128s go into 45? None. So I put a 0. Then we go to the next column. How many 64s are in 45? None. We can't fit any in. So we move to the next column. And then we think, how many 32s are in 45? Well, we can fit 1 in. So we put a 1 in this column and we subtract 32 from 45. Okay, so that leaves us with 13. So that's where we are at the moment. So we go to the next column and we think, okay, well, how many 16s can we fit into 13? None. So we put a 0. So we move to the next column. How many 8s can we fit into 13? Well, we can fit 1 in, so we put a 1 in this column. And what we do now is we take the 8 from the 13, so that will leave us with 5. So we move to the next column and we go, how many 4s can we fit into 5? Well, we can fit 1 4 into 5 and we'll have 1 left over because we've taken 4 away from 5. So we move to the next column. How many 2s can we fit into 1? None. So we move to the next column. How many 1s can we fit into 1? 1. Okay, so we take 1 from 1 and we have 0 left. So this number here, this is the binary number for 45. Okay, so this is how we would express that denary number to a computer in binary. And we use binary because the switches or transistors in a CPU can be in only one of two positions, either on or off.